Welcome to the future of factory automation.
This program is a broadcast of a Japanese podcast that has been translated into English using Notebook LM.
Today, we're diving deep into some really practical stuff in factory automation. Things like how much buffer capacity you should actually build into your equipment.
Right, and also how you handle, the learning curve and passing on knowledge when new tech comes in.
Exactly. We've got these excerpts from a pretty candid discussion between two people who really live this stuff every day.
Yeah, and what's great is we get these real-world perspectives, not just theory. So for you listening, maybe you're prepping for a meeting or just trying to get up to speed.
Or maybe you're just curious about how modern factories actually work behind the scenes.
This should give you a really solid handle on the practical side without, drowning you in jargon.
That's the plan. Our mission today is to unpack the key things to think about and sometimes the different ways people look at equipment specs and bringing in new technology.
Trying to pull out those crucial insights that could save time, money, maybe a few headaches too.
Definitely. Okay, so let's get into it. The conversation kicks off with a pretty fundamental question. When you're specing out new equipment, how much extra capacity do you actually need? How much buffer?
And right away, you hear this difference in opinion. One person felt, the trend is lean, minimal excess, push the equipment.
Really squeeze the efficiency out of it.
Yeah, that lean philosophy. But then the other speaker comes in and says, well, hang on, from my experience, especially with PLC controllers.
Those are the brains, the programmable logic controllers.
Exactly. They said they typically aim for something like 30% reserve capacity.
Whoa, okay, 30%. That's quite different from minimal excess.
It really is. And if you think about it, it highlights that classic trade-off, doesn't it? Saving money up front versus flexibility later.
Right. Lower initial cost looks good.
But in manufacturing today, things change so fast. Products, upgrades. Without that buffer, you could end up spending more later dealing with more problems.
So, skimping early on might feel smart, but it could bite you back. False economy, maybe, especially now.
That's the core insight, I think.
Yeah.
It often is a false economy in the long run, given how dynamic things are.
Makes total sense, like buying a laptop with barely enough RAM from day one. You know you'll regret it.
Exactly.
Yeah.
And they also talked about how this buffer idea, it kind of changes depending on the machine itself.
Ah, okay. So it's not a one-size-fits-all approach.
No. They drew this interesting line between dedicated machines and the more general-purpose ones.
Okay, so dedicated machines, built for one specific part or task.
Yeah. For those, the focus is often tighter specs, keep the cost down, if it's only ever going to do that one thing.
You don't need a ton of extra capability. Makes sense.
But then you look at general-purpose machines, like, say, CNC machining centers.
Right, the ones that can be programmed for lots of different jobs.
For those, the thinking leans towards having more yoyu, that Japanese word for a bit of leeway, some reserve.
Wiggle room.
Exactly, wiggle room. Because you're much more likely to adapt those machines later for different products, different processes.
So the takeaway is, match your buffer to how long you expect to use the machine in its current role and how flexible you need it to be.
Precisely. Because product life cycles are getting shorter, right? So that general purpose gear needs to be adaptable. And this ties right into the argument for investing more in controllers, especially the PLCs.
Okay, yeah. This part was really interesting. They made a strong case for getting PLCs with, more power than you think you need right now. Why was that?
The main point was that equipment today, its useful life for its original purpose might be shorter than it used to be.
Because product lines change, designs get tweaked.
Constantly. And those changes often mean you need to modify the equipment's programming, maybe add a sensor, change a sequence. If your controller's already maxed out.
It becomes a huge pain, maybe even impossible without a major upgrade.
Exactly. Having that extra capacity in the PLC just prevents those headaches during those smaller, inevitable changes, or even just for troubleshooting. You're not hitting the ceiling all the time.
It's like future-proofing, but maybe more like present hassle-proofing. And the cost difference for a more powerful PLC, they said it was pretty small, right?
Surprisingly small.
Yeah.
Often less than 1% of the total cost of the machine.
Wow. Less than 1%.
Yeah. When you look at the whole investment, it's minor. A small extra bit up front that can save you a lot of time and, frankly, money when those modifications inevitably come up. We also pointed out that manufacturers have different philosophies here.
Oh, yeah, like Siemens versus Keyence.
The comment was that Siemens tends to, Bump up the controller capacity in newer models, gives you more room.
Whereas keyints might be more consistent, maybe keeping capacity more static across lines.
That was the observation, yeah. It just shows different strategies in product development.
And that led to that really clever tip about figuring out these differences.
Huh. Yeah, that was a good one. The suggestion wasn't to ask Siemens about Siemens or Keyence about Keyence.
No, it was ask their competitors' sales reps.
Exactly. Because, sales teams, they're always digging for dirt on the competition. They collect info on where the rivals fall short.
So you talk to the Siemens competitor, and they might tell you exactly where they think Siemens is weak and vice versa.
You can get some surprisingly candid insights that way. Maybe more objective than asking the company directly about their own perceived weaknesses.
Brilliant. Get the inside scoop from the other side.
Yeah.
Okay, so then the conversation took a turn towards soft PLCs. What exactly are we talking about there? It sounded a bit fuzzy.
Yeah, they acknowledged it's not always a super clear term. One definition they used was basically PLC logic running on a general-purpose OS, like Windows or Linux.
Instead of the traditional dedicated PLC hardware and its real-time operating system.
Right. But as they said, the lines are really blurring now. Even traditional PLC makers are often putting general-purpose computing elements inside their hardware. You might have Linux running alongside the real-time control part.
So that old, clear distinction, it's kind of fading away.
It seems to be. They mentioned the history, too, how soft PLCs used to have an edge in just connecting easily to PCs before things like industrial Ethernet became standard.
Ah, okay. Because getting a traditional PLC to talk nicely with a PC used to be more complicated.
It often involved special protocols, yeah. A soft PLC running right on the PC just made that integration simpler back then.
But what about connecting to the actual factory floor? The sensors, the valves, the I/O, that seems like a challenge for a regular PC.
That's always been a key point. Your standard desktop isn't built for industrial signals or the factory environment. But then came industrial PCs, IPCs.
Okay, so rugged computers built tough, often with industrial I/O ports built right in.
Exactly. And that development really blurred the lines. Now you've got these robust PCs that can run Windows or Linux. They have the I/O, and they can host PLC software.
So we've got PLCs getting more PC-like, and PCs getting more PLC-like with IPCs. Interesting convergence.
Definitely. So we've talked hardware buffer. Now, thinking about the software controlling it all, that's evolving too, right? Which brings us to virtualization.
Yeah, this sounded very future-forward. Running multiple virtual PLCs on one powerful IPC, using things like Cotis Virtual Controller or what Siemens is offering.
It mirrors trends from the IT world, doesn't it? Centralized management, containerization.
Like Docker or Kubernetes, but for factory control, packaging up PLC applications.
Kind of like that, yeah. The potential win is managing PLC code more like IT manages applications. Think centralized updates, easier maintenance, maybe using computing power more efficiently.
So managing your factory floor software, almost like cloud apps, but running locally on these powerful IPCs? Cool idea. But they did pour a little cold water on it, didn't they, in terms of feasibility right now?
They did. They pointed out the processing power needed to run multiple. Demanding PLC tasks virtually is still significant. And the idea of one single PC running a whole large production line, maybe not realistic yet.
Too many eggs in one basket, perhaps, and just needs a lot of horsepower.
Right. So the more likely near-term thing might be, well, still having distributed hardware, several IPCs maybe, but managing the software centrally.
Okay, so hardware spread out, but the brain controlling the software deployment and updates is centralized. That makes sense.
And this connects to that idea of distributed control using smarter I/O devices out on the network.
Sounds flexible, maybe more scalable, putting intelligence closer to the action.
Potentially, yes. But the big hurdle they flagged was software management. If you have hundreds of smart devices, each running its own bit of logic.
How do you manage all that? How do you see the whole project? How do you update it reliably?
Exactly. Success isn't just having smart devices. It's having the tools to manage all that distributed software as one coherent system. That's the tricky part.
So let's loop back to where we started. Buffer capacity. How does this potential future, this distributed or virtualized world, change that initial question?
Well, it's interesting to think about. If you could get to a truly scalable, virtualized, or distributed system, maybe the need for that big upfront hardware buffer in each PLC shrinks.
Because you could allocate resources more dynamically.
Potentially. You might move towards something more resource-based, almost like cloud computing, pay for the processing power and memory you actually use when you need it. allocated dynamically.
Wow, PLC as a service almost. That's a fascinating shift.
Hmm.
Okay, so that covers the hardware and software side. But then the discussion switched gears completely, didn't it? To the people side. Training and knowledge transfer.
Yeah, equally important, right? What does it actually cost, not just in money, but time and effort, to get people up to speed on new equipment and tech?
And the first take on it was pretty straightforward. The pay-to-learn idea.
Basically, treat the training from the equipment maker as a necessary cost. You buy the machine, you pay for the training. Part of the deal.
Just factor it into the budget.
Right. It acknowledges that, yeah, you can try to learn things yourself, but especially with complex new stuff, the manufacturer's expertise is often essential. You kind of have to invest in it.
But then the conversation shifted slightly, didn't it? It wasn't just about the cost of training.
No, it moved to what might be a bigger problem.
Mm.
What if you do the training, spend the money, but then you still can't actually implement or properly use the technology?
So the training happens, checks the box, but the capability doesn't really follow through onto the factory floor effectively.
That's a critical point.
Mm.
The training costs might seem high, but failing to get the value after the training, that's potentially a much bigger waste.
They framed it as an investment, right?
Mm.
Training isn't just an expense. It's investing in your company's ability to do more complex, higher value work, to stay competitive.
Exactly. The feeling was, if this technology really is the future for your industry, you just have to figure out the training cost. It's a hurdle you need to clear.
But that leads straight into that issue they called Sojinko.
Yeah, the Japanese term for when expertise gets stuck with just one or two individuals.
Happens all the time, I bet. New machine comes in, one person really clicks with it, becomes the guru.
And everyone else relies on them, which is risky, obviously.
So how do you combat that? The discussion really emphasized standardization.
That have to be the goal, they argued. It's okay, maybe even natural, for a few people to get skilled first. But the aim should be to spread that knowledge, standardize procedures so the whole team can handle it.
Make it less dependent on individuals.
Right. And crucial to that is making the expertise visible.
What does that mean exactly?
Encouraging those people who do have the new skills to actually, show others, share what they can do, document it maybe, create a workplace where skills aren't hidden.
So don't necessarily fear the initial guru phase.
No, the problem isn't the guru. The problem is if the knowledge stays only with the guru, failure to transfer is the issue.
And their practical advice was kind of a two-step process.
Yeah. Learn first, then standardize. Let people get proficient, figure out the best ways to use the tech.
And then focus on creating the standard work instructions, the training materials, the checklists for wider use.
You can't really standardize something effectively until someone actually masters it first. You need those early adopters.
Makes sense. Then there was that slightly provocative idea near the end of that section.
Oh, yeah. If it's valuable, it will be relearned thought.
Tell me about that again.
It's the idea that if some piece of specialized knowledge held by one person is truly critical to the business, and that knowledge gets lost, maybe the person leaves.
The sheer need, the gap it creates, will eventually force someone else to figure it out again. Necessity is the mother of invention, or reinvention in this case.
It's a bit stark, maybe a bit cynical, but there's probably some truth to it. If it's essential, the problem caused by its absence will drive a solution, even if it means relearning from scratch.
So summing up that whole training and knowledge part, training's an investment, not just a cost. Expect some initial individual experts.
But make that expertise visible. Actively work towards standardization so the knowledge spreads. That's key for the long haul.
And don't just think about the cost of training. Think about the cost of not being able to use the technology you've invested in.
Absolutely.
Okay, so let's recap this deep dive. We've dug into, well, the surprisingly detailed considerations around equipment buffer capacity, balancing that upfront cost against future flexibility. Very important.
And we explored that strategic approach to new tech training as an investment, managing that initial Sojinko, and pushing towards standardization for real team capability.
It's really clear how linked those two things are. The hardware specs and the people's skills for making factory automation actually work well.
You really can't separate them, can you?
No, you can't. All right, on that note, here's a final thought for you to mull over. As the lines between traditional PLCs, IPCs, and the potential of virtualization continue to blur, the ability to strategically plan both your hardware investments and the development of your team's skills will be the real differentiator in the future of factory automation.
So the question becomes,
what assumptions are you currently making about the lifespan and adaptability of your existing systems?